Good evening, be enthusiasts. How about taking this flight? Let's take it around. Let's do some maneuvers. Let's take it on a roll. Let's do a spin. Let's do a barrel roll. How would it feel? How might it feel to be a pilot going round and round, doing all these maneuvers, fighting the enemy? Isn't it thrilling? Look at this vertical circular motion. Look at this barrel roll. It's so thrilling. I'm pretty sure, so thrilling to do this. And today we are going to start a new topic, and that is circular motion with me, Shreyas, your master teacher for physics at Vedantu. Welcome aboard everyone, a very warm welcome. And those of you who are very new to this channel, my name is Shreyas and I'm the physics master teacher. I'm from NIT Nagpur. I have completed my mechanical engineering. My all India rank was 3,900 when I wrote my JEE. And many of my students are now in the top most colleges of the country, and I have been teaching for quite some time now, in case you do not know about it. And also I keep posting regularly, keep updating you about all the cool and amazing stuff, not just about physics but also about my life on Shreyas_Vedantu. That's my Instagram handle, in case you did not know that. And today we are going to start with circular motion, the kinematics of it. Tomorrow we are going to do dynamics. Sunday is a very special class where we are going to do the JEE advanced problems of kinematics and Newton's laws of motion. So do not forget to miss it. I'll be posting the timing very soon. So do not forget to join the Telegram group and also stay updated through Instagram, and also keep checking the channel very regularly. And how do you do that? Well, the Telegram link is there in the description box below. You will get all the solutions. Like yesterday I gave you a homework problem. I have posted the solution in the Telegram group. I hope you have checked it out. So join it in case you haven't. Alright. And also like and subscribe this channel, because guys, if you do not like or subscribe, you will not get to know when the next video is. So welcome. Hello Achyut, Vish, Akansha, Amruta, and so many students out here. Hi Shailush, Juhi, Anuradha. So the chat section is over here for me. So whenever I look here, I'm actually seeing all your chats, guys. All right. So keep it flowing. Very good. Very good. Welcome Dimple, Aarti, Joy, VSG, Sanya, Akansha, Palak, Himanshu, Kriti, Kanishk, Prakash, C. Harikumar, Himanshu, Poetry, Nidhi, NM. Welcome. Welcome Vish. Welcome. Welcome everyone. Okay. So let's begin our session today. And today, like I said, we are going to do circular motion. And there are so many examples of circular motion, guys, around you, like the motion of planets. Alright, though they are, strictly speaking, they are elliptical, but for most of the problems in JEE, we take it as circular motion. Alright, it's not so elliptical also, it's almost circular motion. The motion of you around the earth is also circular. The motion of moon around the earth is also circular. Also, how about the motion of the giant wheel? If you have ever been in one, how many of you like giant wheel rides? Let me know. How many of you like giant wheel rides? Let me know. I'll see it in the chat box out here. Yes, even a satellite moving around the earth is also circular motion almost. Yes. Wow, wow. How many of you are scared? Okay, Juhi is scared. Okay, looks like everybody is thrilled by giant wheels. Merry-go-round is chiller party. Merry-go-round is for small kids. Giant wheel is thrilling. And how about those giant wheels in those amusement parks which make you go upside down and then they also roll? Have you been in those kind of thrilling rides? I have been in one. So I have been in one in Wonderla in Bangalore. It's crazy, guys. I mean, it just takes you up. It moves you around like this. It possibly tries to rotate you in all possible orientations. It's crazy, trust me. Yeah, so that's a combination of many circular motions. Okay, and how many of you have witnessed this, the circular motion, the valley of death or the circle of death, whatever you call it? Yeah, how many of you have seen this? Wonderla is there in Kochi too. Okay, Science Priya enjoys everything. Well, wish it was thrilling, and believe me, wish I had food before those rides and nothing happened. I was all chill. I don't get scared usually when I enter these rides. I'm like, okay, fine, it's something cool. Yeah, okay, fine, great. Okay, yeah, so that's how my reaction was. Yeah, so this is also a banked road. Yes, we are going to see banked road examples in the next session, but yeah, all these are good examples of circular motion. We'll also see some examples about, you know, going in a circular loop like this. What if I want to go like this, and what if I don't want to fall off? What do I do? What is the speed? All these kind of examples is what we're going to see. Now, to start with, we are going to start comparing the terms, guys. That's what you're going to see. See, in translation, what did we start with? We started with position. Then we said change in position. What is that called? Displacement. Then displacement per unit time, that was velocity. Then make the time interval small. What did it become? Instantaneous velocity. Then change in the velocity was called the rate of change of velocity was called acceleration. And when you make the time interval very small, then that instantaneous rate of change of velocity was called as instantaneous acceleration. So the exact same flow is also applicable here. So pay attention, because there are some minute differences which you might not notice in most of the books or in the regular classes out there. So pay attention, there are some minute details which I'm going to tell you. Now, when a particle goes in a circular motion, right, it is best to represent the current position in terms of two variables, not x and y. X and y is good if the particle is translating or moving like a projectile. I know the x coordinate, I know the y coordinate. But if a particle is going in circular motion, it's best if you represent it not in terms of x, y, z, but in terms of the distance from the center and the angle which it has swept. Yes, so that is called as the polar coordinates, in case you have heard of the term. But even if you haven't, so understand, when you represent the position of a particle in terms of x coordinate, y coordinate and z coordinate, that is called as Cartesian coordinate system. But there are different types of system, and one such system is polar coordinates. So in polar coordinates, what happens is, you show the position of the particle. You tell, oh, the particle is 5 meters away at an angle of 30 degrees. Then you'll be like, oh, the particle is still at 5 units, but now it is at 40 degrees. Now the particle is at 5 meters, but now at 45 degrees. So it keeps changing the angle. Distance remains the same in circular motion, assuming it is not changing the circles itself. I hope this is making sense. Yeah, I hope this is clear. Very good, very good. Some of you already studied that in different subjects or in different places. So now imagine this, guys. There is a particle out here. Okay, so there is a particle out here, and this represents the distance from the origin, and this is my reference line. This is my reference line, just like you have it in trigonometry. You have the first, second, third, fourth quadrant. You have this reference line, and remember, in trigonometry all the angles are measured with respect to the reference line. Similarly, we are doing the same thing. I've chosen this as a reference. You can choose this also as a reference, but come on, let's just use the standard reference. And then what happens is, the angle which you make with the reference, I will call it the angular position. So when a particle is moving in a circular path, so this r, understand, will also become the radius in this situation, and this theta will be called as angular, what will it be called? Angular position. Okay, where is it? It is at 30 degrees, pi by 3 radians, pi by 6 radians, pi by 4 radians, pi radians, 3 pi by 2 radians, 2 pi radians. So it is always measured like this. Okay, so if I tell you theta is 3 pi by I don't know, 3 pi by 2 radians, that means the particle has covered all these things and it has come over here. This is 270 degrees. That's the meaning of that. Okay, so in that quadrant it will be somewhere over here. Okay, so this is that entire angle which it has covered. Okay. So that is angular position. Generally it is expressed in radians or in degrees or in revolutions. These are the units. I hope this is fine. So Bhargav, Flash series is the series for all the aspirants of 11th, 12th and dropper students. We are going to cater the needs of the 11th, 12th and dropper in these series. We are going to teach you 11th and 12th and the dropper portion, all of it, slowly and steadily before your exams. That's what this Flash series is. Okay, so don't worry, you will find the assignments if you keep yourself updated on the Telegram group. Now, the next thing, what if the particle moves? Well, the particle was earlier here. Now the particle has moved a bit. So that comes, there comes angular displacement. So what is angular displacement? Now, initially the particle was here. Now, currently the particle is here. So this vector, I can call it as the initial position. This vector, I can call it as the final position. I know this is my displacement. Okay, this, strictly speaking, this one will be my displacement, but I'm not interested in displacement. I'm interested in angular displacement. That's a completely different thing. So what is this angular displacement? It's simple, guys. If this entire angle is final angular position and only this much angle is initial angular position, then just this much, I call it delta theta. So this delta theta is nothing but angular position, and it is your final position minus initial angular position. Again, it is expressed in radians. To give you an example so that you get it in your head, imagine the particle at t is equal to 0 was here, making angle 30 degrees, and let's say after some time the particle came over here, let's say at 45 degrees, let's say at t is equal to 1 second. So the angular displacement will be 15 degrees. So that's the angular displacement. Keep that in mind. Okay, now imagine I'm going to put a very tricky problem in front of you, and let's see how many of you give the answer. Okay, this is a very tricky problem. Many people fail to give the answer. Let's see how many of you give it. Let's say there is a particle here at t is equal to 0. Okay, it goes like this, goes like this, goes like this, and comes back over here. Now, if I ask you, what is the angular displacement? What is your answer, guys? Please let me know in the chat box. I'm going to read your chats. Yes, Jay, I will be. Yes, Zafar. 0? Wrong. Very few people have given the correct answer, like Manit. Very good. The correct answer is 2 pi radians or 360 degrees. Think about it. The angular displacement is not 0. Understand, it's a completely different concept. Displacement is 0. Translation mein. That's translation. This is angular. Think of it. If you rotate something, it's like a screw. Okay, if you rotate something like a screw, what will happen? When you rotate it by 1 revolution, your screw would have moved somewhere. Okay, so it's not exactly at the same place. So think of it this way, that my angular displacement is 360 degrees or 2 pi radians. But if I now again move back over here, so again think of moving the screw back, then my total angular displacement will be 0. So if I just move once, that is 360 degrees displacement angular wise. But if I again come back, then my total displacement angular wise will be 0. So get that thing in your head. Okay. Yeah, you can even move negative. Yes. So if you are, instead of moving like this, if you move like that, okay, so then it will be negative. Yes, Jay. Yes, MD Shoaib, work and power energy is completed. Okay, so remember that. So generally, it so happens that we end up measuring anti-clockwise as positive and clockwise as negative, because that's the convention we use in trigonometry. But you can define clockwise to be positive. No harm in that. Just like you can decide your left side to be positive and right side to be negative. It doesn't make a difference. But Unless specified otherwise, generally we take this as positive and clockwise as negative. Okay, I hope this is fine. Great, chalo, let's go ahead. I'm pretty sure this was something new which you did not know, and you would have definitely made a mistake if this kind of question came in JEE Advanced or JEE Mains. Okay, so next question, next concept. So we will talk about now how quickly the particle has moved from one position to the other position. So what will it be called? Think about it. Yes, it will be called angular velocity. So what is angular velocity, guys? So just like before, understand, this was the final position, this was the initial position. So this much was delta theta. So remember, delta theta was the angular displacement. But how much time it took? Maybe when it started here, the time was t, and when it came here, the time was t plus delta t. So it has taken an extra time, delta t, to cover this. So if I divide it, guys, if I divide it by the time which it has taken, okay, so that is called as angular velocity, and the symbol for that is omega. But this is actually average angular velocity because you have moved quite a lot of angle in a big time interval. So this will be average. How many degrees did you cover per second? That is angular velocity. So for example, I tell you angular velocity of a particle is pi radian per second. Imagine I tell you that. What does it mean? It means that the particle has moved pi radians, which is how much? 180 degrees in 1 second. So if you wait for 2 seconds, it would have completed one entire circular motion. That's what omega means. So omega, or angular velocity, is nothing but how much angle you cover per unit time. Generally we specify it in radians per second and not degrees per second, unless specified otherwise. Very good. Now that you are slowly getting the hang of this, I'm going to go ahead. Next thing obviously will be instantaneous. So if you wait for a large time interval, you will get a big angle upon big time, which will be average value of the angle which is covered per unit time. That will be the average angular velocity. But if you make a very small angle and that angle will be covered in a very small time, that will obviously give you instantaneous angular velocity. So talking about instantaneous angular velocity, guys, here this is my initial, again this is my final. This angle over here is no longer delta theta, it is d theta. Yes, you guessed it correct, it is d theta. Remember, d stands for infinitely small. So I'll write it over here. D theta is nothing but delta theta tending towards 0. That is what d theta means. Very small angle. And how much time it took? Well, I can write it over here. Maybe it was here at some time t, and then it came over here at t plus dt. What is this dt? Very, very small time. Okay, and then obviously I can define instantaneous angular velocity. And how much will that be, guys? Instead of delta theta by delta t, it will be d theta by dt. That's the correct answer. So that is at that moment what is your angular speed. Maybe you are not covering same angle at same time, so your instantaneous values can be different. Example, well, just turn on the fan. Do you think it will cover same angle in the same time initially? I don't think so. Initially it will move slowly, then it will cover more angle and then more angle, and slowly it will increase the speed, and eventually the speed remains constant. So initially I don't think the fan has same angular velocity, constant angular velocity. Eventually it maintains its angular velocity. I hope this is clear. Yes, Karan, if you follow regularly, why not? Okay, we are going to come. Bhargav, we have already done the calculus part of kinematics in the previous session, so please check the playlist. I've already done derivatives, maxima, minima, etc. Everything, it's done previously, so please check it out. And all the old V enthusiasts, please answer all these doubts. In case somebody is asking, tell all the new family members, if they ask something, tell them yes, it is already there. Oh, you can find it here. Help them be friendly with all the new timers. Okay, yes, very good, very good, very good. Chalo, let's go ahead. Now that we know what is instantaneous angular velocity, obviously what is going to come next? Think about it. Angular acceleration. Correct, you guys guessed it. So let's see what is instantaneous angular acceleration in general first. So imagine a particle has some angular velocity initially. After some time it gets some different value of angular velocity. Example, an accelerating fan or the accelerating wheel of your car. Okay, so let's say it took some time delta t. So angular acceleration has a symbol alpha. So for velocity, what was the symbol? Omega. For acceleration, what is the symbol? Alpha. The average value of angular acceleration is change, which is omega final minus omega initial by the time. Okay, so that's what it is. And you can see that this part over here, okay, represents the change. And this part over here represents the time which you have taken. So just to give you an example, imagine a particle has 2 pi radians per second speed, and then it increases its speed to, let's say, I don't know, 6 pi radians per second, and the time taken, okay, for it, example, is just 2 seconds. Then what is the acceleration angular wise it has? The answer will be final minus initial, which is the change, upon the time, which is 2. So 6 minus 2, 4, 4 by 2, 2. So it is 2 pi, but unit, be careful, it is radians per second square. Just like in translation you had meters per second square, here you have it as radians per second square. So keep that in mind. The unit of angular acceleration is radians per second square. Alright, we can see a lot of similarities between translational motion and circular motion already by now, if you have been attending all my sessions carefully. Okay, very good, very good. Yes, yes, Achut, correct. Rate of change of angular velocity is called angular acceleration. Exactly. So wherever you see the word velocity, you can replace it with angular. That's it. You will get the same terms what you would have got in translation. Now, what is the next? Obviously, instantaneous angular. So think about it, guys. If the particle has angular velocity omega, and now it changes its angular velocity by d omega. So what is this d omega? Well, this d omega stands for the small change. It's not any change, it's actually a very small change. And the time taken for this is, let's say, dt. dt is nothing but the time which you have taken for it. So that will give me the value of, at that moment, what is my acceleration. So instantaneous will be, instead of big change, you will have small change, and instead of a big time, you have a very small time. Again, unit is radians per second square. Alright, just like before. This is instantaneous angular acceleration. Is this clear, guys? I hope. Alright. Dimensions of angular velocity, Gopal, I just mentioned it is radians per second, right? I just mentioned it just some time back. Alright, very good. Okay, very good. Chalo. Now, guess what? Guess what, guys? Let's do a problem. Okay, let's do a problem and see what do we get. Believe me, though this problem initially might look complicated for some, believe me, it is not. If you try and relate x, position and angular position, velocity and angular velocity, acceleration and angular acceleration. If you relate them, believe me, it is very easy. So let's try this out. What is given? Let's try to visualize this first, although it is very simple. It says that there is a particle whose angle covered, okay, is dependent. Okay, so this is a particle. That angle covered is dependent on the time. You tell me time, I will give you angle. At this time, oh, it is here. At this time, it is here. What is the velocity and acceleration angular wise after 3 seconds? So think about it. I don't think anything is constant here. I feel we should use derivatives. Why should we use derivatives? Because things are given as a function of time, guys. So let's start using derivatives concept and let's see what do we get. So if theta is given, to find omega, what will I do? Derivative of position with respect to time, isn't it? Change in position upon time will be velocity. That's all. But this is all angular wise. So just put derivative d by dt of this entire big thing, t raised to 4 by 2 plus t square plus 3. Now you should know how to get derivatives orally because I have already been telling you, and you should have practiced quite a few problems. So this half just comes outside, and t raised to 4's derivative, use the formula x raised to n's derivative is nx raised to n minus 1, and that should give you 4t cube. Correct? The power of t reduces and that 4 comes outside, and t square's derivative is just 2t, and 3's derivative of course is 0, and now you have got the answer for omega, which is 2t cube plus 2t. Okay, cool. But I'm not done yet. I want to find even the acceleration. So alpha, remember, is d omega by dt. Remember, derivative of velocity gives you acceleration, but this is all angular wise. So just take the derivative of this guy, which is 2t cube plus 2t. So think about it. 2 is a constant. T cube's derivative will be 3t square and plus 2, because t's derivative, guys, is 1. Alright, and that's it. 2 3's are 6, so it will become 6t square plus 2, but that's alpha. But we are not done yet. We are not done yet. We have to find, yes, most of you already given the answer, very good. So I'm just taking it slow because there are some new timers also out here. Very smart people we have in today's session. So we have to find it at 3 seconds, guys. So using this omega at 3 seconds, just substitute time as 3. If you put t as 3 cube, guys, is 27. 27 into 2, come on, 54. And 3 into 2, 6. So 54 plus 6, I believe, should give you 60 radians per second. That's what you will get. And similarly, you have to find alpha at 3 seconds. So just substitute time as 3 because that's what has been asked. At 3 seconds, what is the acceleration angular wise? So 3 square, 9. 9 6, come on, and plus 2. What is the answer? Very good, very good. 54 or 56. Yes, 56. Bilkul sahi jawab. Excellent. But be careful with the units. Units will be radians per second square. That's how it is. Okay? Very good. So that is the answer. It is not 2.3, it is 2 into 3. It is 2 into 3. Okay. Once you don't get confused, it was 2 into 3. Alright, alright, alright. Very good. So that's how simple problems are if you relate the two chapters. Else you will be like, oh my god, is there a separate formula for this and all that? Don't worry. Okay. Now, obvious next question should be, do you think kinematic equations are also valid here? Yeah, your kinematic equations. I feel that yes, it should be valid only if acceleration is constant angular wise. Just like all those equations were valid when A was constant, similarly you will have equivalent equations when alpha is constant. Constant rate of increase of velocity. Only then you will have these kinematic equations. So what would be the kinematic equations? Here it is. So instead of V is u plus at, instead of V what should you have? Omega. But it will be final velocity is equal to initial velocity plus angular acceleration into time. That's how it will look like. V is u plus at. That's all. Similarly, instead of displacement, S is ut plus half at square, what should you have? You should have delta theta. Remember, delta theta was angular displacement, will be u, which is omega I t plus half alpha t square. Similarly, guess the third equation now. V square, right, is omega final square is omega initial square plus 2 alpha into angular displacement. And you can also have the additional equation, displacement in the nth second will be initial angular velocity plus alpha by 2 into 2n minus 1. So all the equations are valid, and these are all valid only if alpha is constant. If alpha is constant. Remember that. Isn't it simple? Gopal, you should have read these things little bit before. You should have some idea. Please understand, you're always welcome to our long-term batches, Gopal, if you find that I'm going little bit fast, right? Where I'll be teaching in in length, right? So please understand, these are YouTube sessions, so I'll be touching upon all the chapters, a majority of the concepts, but I have to also maintain the speed. I will assume that you have some idea about these chapters, so please read these chapters little bit and come. Okay? And yes, you always have the facility of watching these things again, but try to make notes and try to read these chapters before only and come. That will help you a lot, trust me. Okay, so if anything is not clear, NM, please let me know what is not clear. I'll tell you, but because all these variables are just analogous to our translational terms, like initial velocity is similar to u, final velocity is similar to v, alpha is similar to a, and then displacement is similar to s. What else? Time is time. What more you want? Okay, so that's how it is. Okay, I agree, Jay. Chalo, let's go ahead. Now, in case you want to enroll yourself into the long-term batches, guys, because a lot of you want, okay, sir, we want numericals, we want this discussion, you want test series. See, everything can't happen on YouTube. Understand? Because we also have our limitations. We try to give, trust me, I try to put in as much as possible, freely as possible, because I know a lot of people want to study over here. They want to study from the best teachers. So we try to do as much as possible, guys. But also understand, these long-term batches are beneficial for you. If you want to go even more in detail, you want to practice even more problems, guys, I cannot do everything on YouTube. You should understand that. So for that, we have the pro subscription course where you will get all your tests, assignments, modules, personal teacher, reporting after the test, micro courses, option of learning in Hindi as well as English, and special courses for KVPY, Olympiads, and all the book discussion courses and all other micro courses which are conducted by different teachers. So this option is always there for you, and even when this option is there, you can also come on YouTube and also learn from the best teachers in the country. So that, see why we are coming on YouTube, you guys should understand, we want everyone to have access at least to bare minimum quality education, right? We want access at least to bare minimum quality education, even if the person cannot afford anything. And yes, if you want those extra pointers, those brownie points, that cherry on the top, you want to polish your preparation, these options are definitely going to polish your preparation, and this is definitely going to help you boost your performance. Understand that. Okay, so for the droppers, these are the prices for 6 months. After 20% discount, it comes to 227 rupees per day. Okay, for droppers, it's per day 227 rupees if you take the 6-month subscription. For 12 standard students, if you take the 6-month, it is 173 rupees, okay, per day. That's per day, remember. Okay, it's very small. And for the 11th standard students, if you take this discount coupon, then you get it at 93 rupees per day. Okay, and how do you get this offer? By using the coupon code. After clicking on the link below, you can select your grade, and that's it. You can get yourself enrolled. It's a very easy process, one-step process. Okay, so this is a coupon code SHHPRO. You will get 20% off, and that's a big number, I believe. So now let's do a problem on kinematic equations. So the initial angular velocity of a particle is 10 radians per second, and it has some acceleration angular wise of 20 radians per second square. What is the angular velocity after 5 seconds? So I'm going to start the timer, and let's see how many of you get this. Okay, so get ready guys. Let's see how many of you get the correct answer. The timer is going to start in 3, 2, 1 now. Manju, the smartboard is meant for YouTube, and for the regular sessions we have a completely different platform called as a wave platform. So that has its own technical advantages, limitations. I hope you understand. Suhas, believe me, if you compare it with the regular offline coaching institutes, you take any big name, okay, they will charge you easily 2 lakh rupees per year, believe me, and they won't even teach you for KVPY or Olympiads, and they won't even give you that personal teacher. They won't even give you those micro courses which we are giving you here. So trust me, I have been in offline coaching institutes before this, and I know how they work and what they do and what kind of practices happen. So believe me, if you compare it with that, these prices are throwaway prices. Okay, looks like many of you got it. Time is up, and let's have a look quickly. Okay, 1 second. Why did Pandu come? Hold on. Yeah, there we go. And here is the thing. I know that the initial angular velocity, that means this is omega I. Then acceleration, that means alpha. After 5 seconds, that means t. Find its angular velocity, that means omega final. So which equation will I use? Obviously omega final is omega initial plus alpha into t. Therefore omega initial is 10, alpha is 20, and time is obviously 5. 25 is 100, 100 plus 10 is 110 radians per second. And I applied these equations because 20 was a constant. Alright, that's how simple it is. Let's slightly increase the difficulty level. This was the correct answer, and many of you got it. Very good, very good. Nidhi, Sneha, Kriti, Aarti, Saurabh, Suhas, Akansha, Jeti, and so many others. I'm just scrolling up. Very good, Prapti, Anuradha, and so many others. Pranav. Okay, very good. I'm just seeing the chat. Very good guys, very good. Okay, let's go to the next question. Next question coming up. The speed of a motor increases from 2400 RPM. RPM, remember. RPM means rounds per minute. So the hint is first convert the rounds per minute into radians per second. Yeah, first convert that. And then it increases to 3600 rounds per minute. So convert it again into radians per second. I'll give you a hint. 1 minute is 60 seconds and 1 round is 2 pi radians. So keep that in mind, that will help you. How much time it took? 2 seconds. What is the acceleration and how many revolutions does it make in this period of time? Chalo, give me both the answers. I will give you slightly more time for this question. Come on guys. I'll give you 2 minutes and let's see how many of you get this. Come on everyone. You can do this. Give me both the answers in one go. This is the alpha, comma. This is the revolutions. Come on guys, if you are also liking all whatever problems I am giving, do not forget to also hit the like button simultaneously, because that's my source of energy. Remember that. Okay, so do not forget to hit that like button, and if you're a new user, do not forget to subscribe simultaneously, or else you'll miss out on all the awesomeness that's going to go on over here. No options, Muhammad. What if it is an integer type of question? What will you do? You know? So no need of options. You should be able to get it even without options. Okay, hardly any time left. Come on, come on, come on, everyone. Second line number in 2 seconds. What is the angular acceleration? How many revolutions does it make in this period of time? This is in 2 seconds. I hope modern world that's clear. Okay, 15 seconds to go. And the time is going to be up. Okay. Let's have a look. Now, what and all is given? First, this one, 2400 RPM. So convert this first. Initial angular velocity. 2400 RPM rounds per minute. So first convert it into per second. So divide it by 60. So that will give me rounds per second. Okay, so you can cancel this out and this will just become 40. So 40 rounds per second. But one round is how many radians? 2 pi. So how much will it become? It will become 40 into 2 pi radians per second, which is nothing but 80 pi radians per second. That's how you do it. Okay, I hope this is clear, guys. Let me know. Okay, now finally again figure this out. Omega final, this is 3600 RPM, but you want to do it RPS first, so rounds per second. So just cancel this and this will become 60, guys, and you multiply by 2 pi, so you will get it as 120 radians per second. That's what you get. Now you can find the alpha very easily. Alpha is final minus initial upon the time taken. This is what I told you. What is the final? It is 120 pi. What is the initial? Well, it is 80 pi. And how much is the time? Time is 2 seconds. 120 minus 80 is 40. 40 divided by 2 is just 20. So 20 pi, that's alpha. Remember, that is radians per second square. That's the answer for the first part. Okay, very good. 20 pi radians per second square. Many of you got it. Now the next part. How many revolutions does it make? Which equation do I use? Which equation do I use? Come on, come on. I feel we can use v square is u square plus 2as. Yeah, that equation is good. So v square, final velocity is, or if you want to use s is ut plus half at square, you can do that also. It's up to you. You can use both of them. If you want to use delta theta is initial angular velocity into time plus half into alpha into t square. This is also fine, guys. So just substitute this. Initial velocity is 80 pi. How much is the time? Time taken is 2 plus half into alpha. What is alpha? We just figured it out. It was 20 pi, I believe, and time again was 2, so it will be 2 square. So think about it. 82 is a 160, so it will become 160 pi. One of the two will go, and 2 into 20 will become 40, so it will become 40 pi. So it will become 200 pi, but that will be radians. So now think about it. Now think about it. 200 pi radians. 200 pi radians is how many revolutions? How many revolutions? I believe it is just 100 revolutions, because one revolution is 2 pi. So 200 pi will be just 100 rounds, correct? That's how you solve the problem. Isn't it simple? I hope you are understanding whatever I am trying to tell you. Okay, great. So that's how problems are supposed to be solved. Hold on, Minecraft, we are going to come to that. Yes, JEE, we are going to cover all the concepts. That's why we are here. That's why the flash series was started for all the 11th and the 12th standard students. I am going to start 12th standard portion from next week onwards. Yes, I have read all your comments, and lot of 12th standard and the dropper students have requested, sir, please start 12th standard portion as well. So simultaneously, we are going to start 11th, we are going to continue with the 11th as well as the 12th. So it's double advantage for the 12th standard students. How? You not only will revise 12th standard portion, or will do a 12th standard portion, but you can also revise 11th standard portion simultaneously. So that's the biggest advantage for the droppers and the 12th standard students. And for the 11th standard students, do not worry, we are also continuing the 11th standard portion as usual at this pace. Okay, so don't worry, we are continuing for both 11th and 12th, both. All right, remember, and droppers of course. Yes, that's what we are going to do. No, it will not be 2 sessions. We will split it, and we are going to use some of the drill slots. I'm planning to give you the solutions of the drills, because what I saw was that giving 5 problems and discussing it for half an hour was taking a lot of time of you, as well as, forget mine, but more of you. I feel that I can use that time for solving more problems over here, all right? And I can also use it for 12th standard. So that's what I'm planning to do. I've taken your feedback very seriously, guys. Okay, so I read all your comments. Yeah, so that's what we are planning to do. All right. Okay. So what about uniform circular motion? Now let's come to uniform circular motion, guys. Okay, so let's talk about, yes, Anuradha, these are JEE level questions only. And Sunday I'm going to take very difficult problems on JEE Advanced. Don't worry. Yeah. Yes, class duration will not change, Shalush. Class will be for 1 hour. I know a lot of people do not conduct classes for 1 hour. But here you can see on Enthuse channel, we maintain that quality of 1 hour at least around. All right. Because I feel in 30 to 40 minutes, it's just time is going to fly. It's not going to be good. You're not going to do justice. Yeah, so I feel if you have to crack the toughest exam in the world, one of the toughest exam in the world, we need to give you that much time. Believe me, I can just end the class in 40 minutes taking few problems, but I am not going to do that, because I have made you guys a promise that I'm going to be here for you. I'm going to teach you till the end, whatever it is, be it in 11th, 12th or droppers. So we are going to maintain that quality of Enthuse no matter what happens. Okay, that's what it is. Okay, so circular motion, uniform circular motion means, example, merry-go-round moving with, or a giant wheel moving with constant speed. Obviously giant wheel does not accelerate, or else the persons will be thrown out. And merry-go-round after some time also goes with constant speed. If it continuously accelerates, then you will be again thrown out. All right, or taking a ball and swinging it by a thread, that is also again a constant angular speed, or I can say it is uniform circular motion. So in uniform circular motion, what remains constant? Thank you. Okay, see, in uniform circular motion, what remains constant? It is the angular velocity. A very good example is this one. I hope you can see it. Yes, Earth moving around the sun. Well, Saurabh, it's not exactly constant. Speed changes at apogee and perigee, so there is a small change. Okay. Chetan, I wish I could conduct for 2 hours, but trust me, Chetan, you cannot talk for continuously 2 hours. My voice will go, okay? My voice will completely be dead, okay? So I understand this is YouTube. I need to maintain that energy. So for that 2 hours, I wish I could talk continuously for 2 hours, but my voice will go. So I try to keep it somewhere between 1 hour to 1 hour 20 minutes. Okay. Great, great. So now let's talk about few important terms about time period. So what are some important terms? Oops, one sec. Yeah. Some important terms which we can see in circular motion. One is time period. So what is time period? Time period means if a particle starts here, how much time does it take to come back? So time period is time to complete one revolution. So the symbol for that is T, right? So the symbol is T and it is obviously expressed. The unit is in seconds or hours or minutes, whatever you want. So that's the time period. So like time period for the moon to go around the earth is 28 days. The time period of the minute hand, how much does a minute hand take? It takes exactly 1 hour. Second hand, it takes 60 seconds. Hour hand takes 12 hours. So that's what it is. Okay, so that's the meaning of time period. Next, frequency. Frequency means how many revolutions does it move in one unit of time. So it is basically number of revolutions per unit time, and the symbol for that is F, and the formula is 1 by time period. And it's very easy. By the way, the unit is per second or hertz or per second, both are equivalent. So for example, the time period is 0.1 second. So particle completes a revolution in 0.1 second. What will be the frequency? It will be 1 by 0.1, which is 10 hertz. It means it completes 10 revolutions in 1 second. Makes sense. If it takes 0.1 second to complete one revolution, so it will complete 10 revolutions in 1 second. That's the meaning of frequency. You can also have different units of frequency. You have just seen that sometime back. RPM, RPS. Yes, you can have different forms. You can convert it into different ways. Alright, so it's up to you how you want to convert it or write it down. Alright, so it's up to you. Now, velocity of a particle is related. Yes, velocity of a particle is related. I'll tell you how. Just one sec. Yes. Okay, so imagine this particle is going in a circular path, and this particle over here has some velocity v, and this distance is r, and I tell you the angular velocity is omega. Okay, so are these terms related? Yes, they are related, and I'll tell you how. Observe it carefully. Think about it. The velocity of the particle, first of all, will be, actually the magnitude of that will be constant. Why? Since it is uniform circular motion. What is the value of velocity? Can I not tell? It is nothing but the circumference divided by the time which you take. And what is the length of that circumference? Obviously it is 2 pi r. And what is the time that you take? T. So velocity is 2 pi r divided by t. You can use this relationship. Alright, this is one way of writing it down. Now let me tell you. Very warm welcome, Jagdish. Okay, so one more thing over here. Let me tell you. Imagine if I ask you what is the angular velocity. Okay, if I ask you what is the angular velocity, it is basically the angle covered upon time. Correct? Now what if I wait for exactly one revolution? Okay, if I wait exactly for one revolution, what will be the angle which it has covered? Think about it. It will be 2 pi. And how much time will it take to cover one revolution? Obviously time, t, time period. So omega is 2 pi by t. This is another important relationship which you should know. And now you would have seen one nice relationship between all these variables. I hope you are seeing it. look at this over here, this number 2 pi by t, what is it? Omega. So therefore, I will also get, yes, the second formula for velocity. Velocity is nothing but omega into r. So that's the second formula that I'm getting for velocity. Interesting. So velocity is omega r, v is 2 pi r by t, which is obvious, circumference by time, and omega is 2 pi by time period. All these are very important formulas. Yes, very good, very good. Now imagine guys, I ask you, okay, just imagine there is a fan like this. This is your fan, ceiling fan. Just one second, let me draw it a little bit properly. This is your ceiling fan, something like this. Tell me guys, if I take a point here and if I take a point here, let's say I call this point A and this point as B, which point has more angular velocity? Come on, answer this in the chat box. I'm going to read it. Which point has more angular velocity? Let me know in the chat box. Which point has more angular velocity? I'm going to read all your chats. It's going to be interesting. Let's see what you guys say. Okay, most of you guys are wrong. Very good, Modern World. Thank you, Chetan. Angular frequency and angular velocity are two different things, okay, unit wise also and physically. Yes, the correct answer is omega A is equal to omega B, guys. Yeah, be careful. They are not different, they will be same. They will cover the same angle. B will come here, A will come here. They would have covered, think about it, the same angle in the same time. Yes, they are equal, but you know what is different? V is different. So velocity of A is less than velocity of B, and you can see because of this. Omegas are same, but R is different. R for A is small, R for B is more. So that's why the angular speeds are same, but linear speeds or the actual velocities are different. The one which is far away will have to go in a big circle, so the speed is more. I hope this made sense. So Pratik, the thing is, on a body, all particles have the same omega. Omega is constant for all the particles on the same body. Understand that. Okay, so that is what it is. So all the particles move by the same angle in the same time. So omegas are same, but the particle which is far away has to move more. The particle which is close has to move less. So VA is less than VB using this relationship or even logically. That's how it is. So let's get to some problems as well. So let's see how many of you get this. Let's see how many of you get this. I'm going to give you 1 minute of time. Starting it in a bit. A point on the wheel whose diameter is 2 meters has linear velocity of 8 meters per second. What will be the angular velocity and what is the time period of revolution? 1 minute. Let's see. Sunil, you can definitely watch the replay again. Try to solve this problem. You'll understand all the concepts. Don't worry. You need to be a little bit quick. It's better, guys, if you read these topics beforehand and come. Believe me, that makes a big difference in your understanding. Come on, come on, come on, come on. This way, you know what? By this timer, I'm preparing you for JEE Advanced by not giving you options, because in JEE Advanced, many times you don't have options. Yeah. Integer type. Even in mains, by the way, those last 5 questions don't have options. They are integer type. Chalo, 10 seconds to go. Okay, time is going to be up. So let's see how to solve. A point on the rim of the wheel, diameter is 2 meters. So essentially radius is 1 meter. Okay. Linear velocity V is 8 meters per second. I just told you the relationship between V and omega. V is omega R. I just gave you this. So velocity is 8, omega is I don't know, R is 1. So therefore omega is 8 radians per second. That's the first answer. Then what is the time period of revolution? I just gave you that formula. Omega is 2 pi by t. So just shift that time there. So time period will be 2 pi by omega. Omega is 8. So it will become pi by 4 seconds. So that's the value of time. You check the options. If options has pi, leave it in terms of pi. If options has decimal values, then substitute the value of pi as 3.14 or 22 by 7 and accordingly calculate. Alright, so think about it depending on the type of the question or the type of the options. So that's the answer for this. Let's go to the next question coming up on your screen. Let's see how many of you can do this tricky problem, guys. It says, what is the average acceleration of a car traveling at 36 kilometers per hour to take a turn by 180 degrees when traveling along an arc of length 304 meters. So it has taken a U-turn. That semicircle's length is 314, special number. I don't know why. You think about it. Okay, starting the quiz now. Let's see how many of you get this. Yes, bilkul, Kirti, correcto. That's a nice word. I like it. Kamalesh, don't worry about my face not being clear. Focus on the problem, yeah? Yes, Muskan, why not? Looks like Harshvardhan, you're a fan of Harry Potter. No problem, Kriti. Everybody is welcome. Come on. Okay, it's not 0 for sure. It's not 0 for sure. All right. Okay, so here is the thing, guys. Let me show you the diagram first. The car was going, well, 36 kilometers per hour. First convert it. It is nothing but 10 meters per second. It was moving at 10 meters per second. And what did it do? It took a U-turn. Okay. And the speed has come back 10 meters per second. And the length of this arc is 314 meters. I feel we can use this to find how much time it took. Yes, how much time it took. The time taken will be distance, which is 314, by speed, which is 10. So it is nothing but 31.4 seconds. So that's the time taken by that car to turn by 180 degrees. Now what is the question? Acceleration, not angular, acceleration, just acceleration. I hope you remember the average acceleration was always final minus initial speed divided by the time. So just substitute everything. Final velocity, well, is minus 10. This is assuming this side is negative and that side is positive. Okay, minus 10 minus initial velocity is plus 10 divided by the time, which is 31.4. So minus and minus will add, actually it will become minus 20 by 31.4. That is the answer. You can substitute the value and you can get it in decimals, but this is what it is. I hope you understood. The mathematics is not important. The how you solve, a lot of people think the velocity will not change. Think about it. It was here, now it has become reversed. So in fact, velocity has changed in direction, but not in magnitude. So it is actually accelerating. That's what important it is. So my point now is that a car going in a circular path, even if the speed is constant, did you not see it is accelerating? Did you not see that it is actually accelerating even when the speed was constant? And what is the reason for that? Because the direction was changing. That is what is important. So once you understand this, it's very easy to understand what is called as centripetal acceleration. So a car going with a constant speed or a particle going with a constant speed, even in uniform circular motion, understand this concept. So V is constant, but V bar is not constant. That clearly tells, and why is it not constant? Since direction changes, and because of that the acceleration is not zero. All right, there is some acceleration, and this acceleration is called as centripetal acceleration. Why centripetal? Because it is towards the center. Okay, it is towards the center. And why is it towards the center? Very simple logic. Imagine this pen represents the velocity, okay? And if I now tell you the acceleration is also in the same direction, what do you think will happen? I think the speed will increase, correct? Okay. Now let's say velocity is here, but acceleration is here. What do you think will happen if velocity is here and acceleration is there? Speed will decrease, correct? So acceleration can't be here, nor can its component be here or there. So the moment any component of acceleration comes here or there, the speed will either increase or speed will decrease. So the only way the speed can remain constant is when the acceleration is perpendicular to the velocity. That way it can only change the direction, but it cannot change the magnitude of it. So that's the reason why I say that the centripetal acceleration is perpendicular to the velocity and the magnitude is given by v square by r. So that's the value of acceleration, but you can use some special logic, like remember v is omega r, so just use that, and what will you get? Acceleration will be omega square r by r. So that r goes and you will get it as omega square r. So you might as well write it as v square by r, which is also omega square r. So this is the formula for centripetal acceleration. I hope this is clear. I hope this is clear. I hope this is clear. Okay, shall we do some problems now? Are you guys ready? No, VSG, there is nothing called centrifugal acceleration. This is what is wrong, and that is what I'm going to clear in the next session. There is nothing like centrifugal acceleration. That's wrong. Okay, great. So you will see that in the next session. Okay, now a particle moves in a circle of radius 100 meter with constant speed of 20. Okay, so what is the frequency? Let's try to think. Moves in a circle of radius. Okay, so the radius is 100 meters. Speed is 20 meters per second. How do I find frequency? Let's think. How do I find frequency, guys? Oh, I can find omega. Think about it. I can find omega. So V is omega R. So V is 20, omega is unknown, R is 100. So what will be the value of omega? I feel it will be 1 by 5 radians per second. But now I think I know one more formula for omega. Think about it. Omega is 2 pi by time period. And what is time period, guys? 1 by time period is nothing but frequency. So I can write it as 2 pi f. So just substitute the value of omega over here. You will get this as 1 by 5 is equal to 2 pi into f. So what will you get the frequency as? Think about it, 1 by 10 pi. But this will be hertz. That's your final answer. Yes. I hope this is fine. That's what the answer is. No VSG, pseudo is something else. I'll come to that VSG, don't worry. There is a separate session for that. Great, let's go to the next part of this problem. Keep all these values in mind. I hope you guys are writing it down. Keep in mind omega was 1 by 5 and frequency was 1 by 10 pi. So just keep that in mind. Omega was 1 by 5. Okay, so the next part. Same data, but the question is, what is the angular velocity? I think I just figured it out. what is the centripetal acceleration. Okay, the angular velocity, I just figured it out. Omega was 1/5 radians per second. I just figured it out. What is the centripetal acceleration? So the particle is going in the circular path with a speed of 10 meters per second. What is the acceleration? That is what the question says. So use the formula. AC is omega square r. What is omega? 1/5. So square it into what is the radius? Well, it is 100. So what will it become? 1/5 square is 1/25. So it will become 100/25, and that is nothing but 4 meters per second square. So that's the acceleration. Wow, so many of you have already given the answer. Very good. Very good, very good, very good. Excelente, excelente, perfecto. Very good, excelente guys, excelente. Let's go to the next question. Are you guys now ready to the best question of today's session? Best question of today's session, and you will see why when you stand near a railway track and you see a train coming from far away, even though it is traveling with the same speed, you feel that when it comes closer, it is traveling faster, and when it is far away, you feel it is hardly moving. Okay, yes, obviously, Achyut, it is important for KVPY. Now, there comes a concept called as relative angular velocity. Now, let's see what it is. Let's see what it is. Here it comes. Imagine, just imagine, okay, your observer, this is your Pandu, okay, this is your Pandu, he's standing here, he's the observer, and there is a particle over here, and that particle is moving like this, along this line. Do you think this r vector, that position vector, do you think it will change? Do you think for Pandu, when he observes that particle, do you think his position vector will change? Yes or no? Reply. Do you think the relative position, do you think that angle will change? Do you think? No, right? So if his angle is not changing, what will be the particle's angular velocity relative to Pandu? What will be the relative angular velocity? What is the rate at which angle is changing for Pandu? What is the Karan? That's on Sunday. What is the relative angular velocity? Come on, think and tell me. What is the relative rate at which angle is changing? Excellent, Pranav, very good. It is 0, Jumna, very good. No, not omega 2 minus omega 1 VSG. Theta is not changing only. So it is 0. It is 0. It is not changing. Angle is not changing. So when a particle moves like this, the length might change, but angle is not changing. So relative angular velocity is 0. Keep that in mind. This is quite similar to, yes, the general relative motion, yes. Now, what about this situation? When you have, okay, when you have the velocity perpendicular to r. Now will the angle change? Yes, of course. If this is r and if velocity is like this, we have just seen it just some time back. We've seen what is angular velocity. Omega was v by r. We have just seen it in your normal circular motion. Right? We have just seen that. Correct? We have just seen that. Now, if it is so, when the velocity is perpendicular, that omega is v by r, then the question arises, what if velocity is not perpendicular to v by r? What do you do? Well, it's obvious, isn't it? You have to split the velocities in two components. Think about it. I will split the velocity into a component here and a component here. Two velocities, assuming this is theta. If I call this as v cos theta and if I call this as v sin theta, I feel v sin theta component of the velocity is not even responsible for changing the angle. Look at that. It's a useless component in terms of changing the direction. It's exactly similar to the first situation. So who is responsible for changing the angle? V cos theta. So what should this omega be equal to? Omega, exactly like over here, it should be V cos theta divided by R. I hope this is making sense. So only that component of velocity which is perpendicular to the distance is going to cause a change in the angular position. Is that fine? Gopal, my energy level will not go down here. Okay, my energy is still high. Okay, very good, very good, very good. Okay, I am always excited as long as I am seeing your hearts, smileys, Josh and comments. So keep liking, keep commenting, then my Josh will be high. Very good. So why does a train moving at constant speed seem to move faster when it is closer? Oh, we have our Pandu and he is looking at the train. Let's see what this cute little Pandu is going to see. Guys, observe, when the train is over here, this is R, correct? This is velocity, but I have to split the velocity. Remember, always split the velocity into two components. So I will split the velocity. Instead of keeping the velocity like this, I will split one component here and other component here. This is some angle theta. So this will be V cos theta and this will be V sin theta. So guys, in this situation, what will be the omega? Can you think? What will be the omega? Which component will be responsible? V sin or V cos for changing the angle? For changing angle, which component of velocity will be responsible? Which component? Come on guys, I'm reading all your chats. I read your chats here. Come on, please let me know. V cos? No. Think again. Very good, Pratik. Jumla, think again. Cos? No. It's not cos. Not both. V cos is not going to change the angle, guys. It's just going to change the distance. Imagine the particle coming like this. How will the angle change? But V sin, well, that changes the angle with respect to Pandu. So it is V sin theta. Do not by heart that it is always cos, because cos or sin depends on which angle is taken as theta. So keep in mind, do not by heart it as cos or sin. Remember, it's always the perpendicular component divided by R. I hope this is fine now. Now think about it. When the train comes here, let's say the distance is R, the velocity is V. Best part, the velocity is already perpendicular. Best part, velocity is already perpendicular. So what will be the angular velocity here? Omega naught will be just V by R, isn't it? Just V by R. Correct. Now think about it. If I ask you which one is more, compare both the terms. If you look at the denominators, this R is small, this R is big. So this R is big, correct? And in the numerator you have V, but there is a sin theta here. So the numerator is smaller here. Oh, interesting. Numerator is small, denominator is big. Obviously this term will be less than omega naught. Obviously. I hope this made sense to you. Did this make sense? Very good. Now think about it. Here, when the train is over here, the angular velocity is less. But when it comes closer, the angular velocity is more. So what will you feel? Oh, it is covering more distance. That's what your brain perceives velocity as. You will feel, oh, it is covering more angle per unit time. Oh, it is moving more, so the speed is more here. But actually the speed is not more. What is more? Angular velocity is more. So speed remains same, but angular velocity changes. That's a very good problem. Obviously Manju, देखो free fund में कर रहा है, but actually Manju, I'm not doing it for free. You have to like the video. Do not forget, you have to like the video. Without that I cannot, है ना? Yeah, even the radius has changed, but your brain perceives, Pratik, velocity as angular velocity. That's what you think. Something is moving fast, you feel that, oh, that means it should cover more angle, but that's what your brain thinks, but actually it's not. Okay? Great. So Guys, do not forget all those students who want to get those crash courses, the numerical course. I'm starting a numerical course this Tuesday for JEE Mains Advanced Problems. Yes, I'm starting a numerical course, micro course this very Tuesday. And I have also started HC Verma discussion courses long back. You can watch all the recordings in the micro courses. So that is, if you enroll yourself into the pro subscription, by using this discount coupon, you will get 20% off. The link is in the description. Do not forget to see that. And like the video, and all the new timers, please subscribe. Without that, you will miss all the awesomeness that I do over here. And Sunday, I'm going to conduct a special session on advanced problems. And tomorrow, guys, wait, there is a very important announcement. Tomorrow, I will be going to V Biotonic. Yes, it's a neat channel, I know. It's a biology channel, Vani Ma'am's channel. I'll be going there and I'll be conducting a special session on physics and Bollywood. Yes, if you are interested to see how Bollywood and physics are related to each other, then do not forget to check it out tomorrow at 9 p.m. Saturday, 9 p.m. tomorrow night. That's what I'm going to do. All right. Great session, guys. Bye. Thank you for coming. Keep coming like this. Spread the joy. Share this with your friends. Make this family bigger. Bye. Signing off. This was Shreyas here, your master teacher for physics. Bye.